Hi everyone! In this video, we will use the normal distribution to compute a value given the probability. 1,000 people took a survey. The scores on the survey have an approximate normal distribution with a mean of 50 points and a standard deviation of 10 points. The middle 50% of the survey scores are between what two values, rounded to the nearest integer? We were told that these scores are normally distributed. This is convenient because then we can use any tool that we need for normal distribution to our advantage. Let's go ahead and draw a normal curve since they are normally distributed. And the center is our mean or mu right here. And we were told this, the mean is 50 points. So the mean here is 50. We were also told the standard deviation is 10 points. So let's notate that here, that the standard deviation is 10 points. Now let's get into the question. We're asked the middle 50% of the scores. Let's go ahead and block off about 50% of the data in the middle. So inside here, let's go ahead and highlight this. This is going to be our 50%. So we have 50% between these two numbers, but we don't know what those numbers are. So we can use one of the tools that we have with normal distribution to find those values. If we are given the area or the probability underneath the curve, we can use inverse norm to find those. But we need to know the percent or the probability to the left of that. So let's go ahead and find the probability, the area, or the percent under the curve for each of these spots. We know that this is 0.5. We know the entire area under a normal curve is 100%. We also know that a normal curve is symmetric on both sides. So the area to the left of this, over here, will be the exact same as the area above. And since all of this needs to equal 100%, we know that the area from both green sides will add together to be 100% minus the 50% that is being taken up with the red part. So we know that both of them together will be 50%. Because this is exactly symmetric, although my graph isn't looking as beautiful as it should, we do know that it will be exactly 50 or symmetric on both sides. So we need to divide this by 2 to get how much is under both of those curves. 50 divided by 2 is 25, so we can put each of these as 25% of the area or probability. And again, let's change those to the decimals. So we have 0.25 here and 0.25 left over here. Now we know right here that for this value, everything underneath the curve to the left is 0.25. But now we need to figure out everything in the area to the left of our second one. This one has 0.25 and 0.5 to the left. So we can add those together, and everything from this point to the left is going to be 0.25 plus 0.5, giving us 0.75. And those will be our probability or percentages that we will use in our inverse norm to find our two values. So now we're going to turn on our calculator and let it do all the work for us. So to find these, we're going to go to second vars for the distribution. This is normally distributed, so we can use the inverse norm, down 3. The area for our first one is the 25% or 0.25. The mu or the mean we were given is 50 points, so we'll type in 50. And then we were given a standard deviation of 10 points. Then we arrow down, keeping it on to the left because we did everything to the left. We'll paste it into the home screen and press enter. We'll run it. And that gives us our value for our first part, which rounded to the nearest integer is 43. Now we do it again for the second value over here. Again, back to our calculator, and we're going to run the same inverse norm. So second distribution or second vars for the distribution. We scroll down to number 3, or you can press 3, press enter. The area on this one is 0.75 because we added 0.5 and 0.25. The mu and the standard deviation are the exact same as the last one, and we keep it to the left and we paste it back in our home screen, press enter to run it, and now we have our score for the one with the area of 0.75 to the left, and rounding this to the nearest integer, that's 57. So we have our two scores for which 50% of the data is between 43 and 57. And now we're all done.